Hi, welcome back. So to address the differences between Oric ROM routines version 1.0 and 1.1, I've created a new library called Oric UniRom, and it's there as a very simple program that dynamically detects what version of the ROM you have installed, and then will call the relevant ROM routine, changing the address and whatever. So let's just take a quick look at that. Here is the code. It's a public repo, so please go on there and do what you want, and that's fine. I will include the link in the description down below. So anyway, let's have a look at the code. So this is the main program. So just a little method there to do a pause for some testing. And essentially the difference is when you're rather than calling these normal libraries within OSDK, if you prefix it with U underscore and it's supported by the UniRom files, then it will call that ROM routine, but it will do an initial check. It also has some assembler routines that process the parameters that are required by some of the drawing and sound functions. At the moment, it's probably about 30–40% done in terms of function coverage. There's a lot more to put in there. I haven't got any of the main sound functions. It's only the sort of the zap and the ping and everything else, just the sort of normal parameterless functions. So let's run it first off, and then I can describe what's happening. We'll just check the config. So I'm running as an Oric-1 here, and there's my main program, and I'm including UniRom as a library, so that will look for those files there. So if I just run it, then it will do its demo. Particularly exciting, and then it just goes to them flashes, and that's it. So I didn't say it was going to be exciting, but hey, it's cool when you start digging into it. So let's have a look at the code. So first off, we'll call a U underscore CLS, so clear the screen. So how does it do that? So if we look there, this is the header file. So you have CLS, which is defined in the in this assembler file here. So what it does, let's look at CLS. So in here, this is the definition for the CLS. So what it first does is it looks in the ROM for the version numbers printed on the screen. There may be better ways of doing it, but it seems reliable enough. And it compares and essentially says that so load what's in that address, which is defined here, that one, and compare that with the string 1. So if that is 1.1, so essentially it's looking at that bit when it prints out on the Oric loading screen. If it is, then it will branch to the ROM 1.1 routine. Otherwise, it will stay here. So its default, if it sees a 1 there, it will go to the 1.1. Otherwise, it will default to this one. So if we then have a look at this this definition, that will hold the ROM address. So if we look here, so there's the ROM 1.0 and that's the ROM 1.1 versions, the routine, the entry points, those routines in ROM. So the address is either that one or that one. So in this way, I've done it with these weird spacings here with the underscore because I wanted to line up, but hey, whatever. So in this way, there's an easy way to modify it. I noticed there were some issues. I think I've addressed that now. So for the commands that are simple commands with their parameters, that's very straightforward. So clear the screen, go to text mode, low res mode, high res, all that kind of stuff. That's great. Ping, zap, shoot, explode, whatever it is. The ink function, which is called here when it does the flashing, that's taking a parameter. So what that does is there's some additional methods to take 1, 2, or 3, or 4 parameters off the stack and loading them into a very special place in page 0, which contains the parameter block, up to 4 parameters, I think. that is used by those ROM routines. So that's how you pass data in. So OSDK will compile it all, and when you run it here, that data is put on the stack, and then that's read out. So let's have a look. So let's jump through this. So it does the determination of 1.0, 1.1 ROM, whatever. It says, right, let's go and load that parameter, jump to the routine, and then set the result. Okay, so what that's doing here, it's setting the output. So the way this works is the first part of that parameter block is actually the status response. So if it's a non-zero result, then that's an error. Otherwise, if it's zero, then fine. So just for tidiness, we set that up. And then we have this offset, and you're looking at the stack pointer here, and it's reading the first piece of data. So it's each byte will go into initially the low part and then the high part of the byte in case it's an address or something like that. So that's the way it interprets it. So if it's just a character, if it's just a byte, I should say, in this case ink, it's a byte, then the low part of that will almost certainly be 0 because you've only going ink is, I think it's 0 to 7 or something like that. There's not many. So you're in point of fact, you're only setting this here. So what this does, you have the first block. If you're loading 2 parameters, that's the first block, first parameter effectively, low and high. And then the second parameter, low and high. And you can see this offset here. So that's status. That's the first parameter. That's the second parameter, and so on and so on. Yeah, until you get down to here, where you go from E2, 2E0 all the way up to 2E6 as your 4 parameters plus an additional output parameter. And then when you've finished calling it, where is the ink thing? You set the output. So what this does is it will look at it will grab the result from the ROM routine. Result is put into the accumulator, and then that is pushed out to that memory address, which is the status response. So I'm not actually doing anything with that right now, but in theory you could interpret that call and take additional action or different action if there was a problem. So, for example, if you called ink with 75 as a value, that would be generate an out of range error. So that's essentially what we've got. It's a very, very simple process. Now, in addition to that, I've also been messing about with some debugging and breakpoints. Let me show you how that works. There's a breakpoints text file here, and I'm using Oric as the emulator. So what you can do is say, right, I want to pause, I want a breakpoint at the high res function. So when it sees that being executed, then it will pause and drop you into the monitor. When it does this, with the compilation generates the symbol file, so it knows the addresses of all this stuff. So you can either specify this address here by the symbolic name, or you can specify an actual breakpoint. So this breakpoint is, if we do a find for that address, you can see here that's actually looking for ink. So this is oh, I keep losing it. So this is the ink for Oric-1 and ink routine for Atmos. It's just a way of testing. So when we do run, that will just run it and it gets ignored. If we specify debug as a parameter, then what it does, when it loads up first off, there we go. So now we're at high res. So it's actually trapped that breakpoint and brought up the monitor. And you can see here, these are the breakpoints that have been populated. If I then press F2 to continue, then it breaks again because it's just found this bit, which is the ink command. So I can do that again, and you can see the change of color. So as it's going round and round this loop, it's stopping each time with F2, it's calling that command, which is really quite cool because you can get into the inner workings of it. Now, using this is a bit of a black art. It can be a little bit tricky, a little bit mysterious at times, but there has been times when it's been really, really useful, especially when you're dropping down to execute ROM routines and your parameters are screwed up, or you need to step through and examine some registers at a particular assembler function you've created. Very, very useful. Anyway, so that's it for now. I'm going to continue and expand this out to include pretty much all of the ROM routines. There are some additional routines in there which are hidden away that you don't see. They're not basic routines, but they're either used by basic or just sort of floating around, which may or may not be useful. One thing I haven't done yet is figure out the response to that. So I think for most things, a status response of 0 is okay. Non-zero, something's broken. But if you were executing a math command and you needed a value coming back, then I need to figure out where that gets stored. I think it gets stored in the parameter block. I don't know at the moment. The documentation, as I'm sure any other Oric programmer has figured out by now, is pretty poor at times, and some of it is misleading and contradictory, which is a real big help. Anyway, so here's what it is. So I'm going to continue, and I'll let you know how I get on. This is a public repo, and I'll say please do fork this and have a look. And yeah, I look forward to your feedback. See you next time. Cheers.